Hello everyone. So I am going to solve few questions here on the concept which we have already discussed in the class, that is series and parallel combination of resistors, or how to solve those circuits where you see series and parallel combination of resistors. So first let's quickly revise whatever we have done in the class before, that when two or three resistors are connected in series, so this is R1, this is R2, and this is R3. When they are connected in series with a voltage source V, this is plus and this is minus. So I told you before that current always travels from positive terminal of the battery towards negative terminal of the battery. So this I current will flow from here to here. The same current will flow in R1 in R1 in R2 in R3, and then it follows the same path and come back to the negative terminal of the battery, right? So first thing which we have revised, which we are revising here and which we have done in the class and derived before, that current is always same in the resistors which are connected in series. So you can see that it's a closed wire, right? So whatever current is flowing from here, the same current will flow all over, right? So the first thing which you need to remember is this. Second thing is that voltage is different, right? Voltage is different in case when resistors are connected in in series. So let's say that what is the value of voltage across R1, what is the value of voltage across R2, and what is the value of voltage across R3. So as per Ohm's law, which says V is equal to I multiplied by R, when we check the value of V1, we see what is the current which is flowing through this R1 resistor. It's I. What's the value of resistor? It's R1. Similarly, what is the value of current flowing through R2? It's I multiplied by R2. This I multiplied by R3, right? So you see that all the voltages V is equal to V1 plus V2 plus V3, or you can say that all the three voltages across three resistors respectively are different and current is same. The other thing which we have which we saw before was that the R equivalent or the total resistance of the circuit will be equal to simple addition of all the resistors which are connected in series. So that is R equivalent is equal to R1 plus R2 plus R3. So this is what we saw all about resistors when they are connected in series, right? Next we'll see the circuit when the resistors are connected in parallel. So if this is R1 and this is R2 and they are connected in parallel, and how do we know that they are connected in parallel? Because their both ends are connected to each other, right? This end of R1 and this end and R2 is also connected to each other. This end of R1 and this end of R2 is also connected to each other. So if the circuit is there in this combination, it is known as parallel circuit. This is V. So here what all we concluded in parallel circuit, the first thing was that voltage is same. Voltage is same in all the resistors which are connected in parallel. So what I told you was that if this is V, that means that this is plus V with respect to this minus, or here we consider as zero potential. So if there is no resistor connected in this entire path, right? So the same plus V will be here, and if there's no resistor connected in this entire path, the zero is here. So whatever we see, whatever the value of V or voltage we see here, the same value of V will be here, the same value of V will be here, right? At both the terminals of resistor, you see the same value of voltage here also and here also. So in this case, we can conclude that voltage is same when resistors are connected in parallel. And what about the current? So let's say this I1 current is starting from the positive terminal of the battery. This is the same current, this is the same current, but here at this junction, you see that the current sees two paths. One is this and one is this. So therefore the current is going to divide I1 and I2. From here I1 current is going to flow. From here, I2 current is going to flow. And again, at this junction or after this junction, it becomes I. So what is the value of I current? I1 plus I2. Here also, before it is bifurcating, this is I1 plus I2. So here we can conclude that voltage is same, but the current is different, right? When resistors are connected in parallel. So, and one more thing which about resistor or equivalent resistance, it will be R equivalent will be equal to 1 upon R1 plus 1 upon R2. If there would be more than 2 resistors, let's say that there would be one more R3 resistor, it would be 1 upon R3 as well, right? So this is the equivalent resistance, how we can calculate the value of equivalent resistance when the resistors are connected in parallel. So yeah, this is all we have done already in the class. Now let's take quickly some questions, directly formula based questions. So here you can see that there are two resistors which are connected in series, which is R1 and R2. The voltage is 12 volt, and what we have to find here is find value of current and voltage across R resistor. So first step will be find equivalent R, right? Or you can also say R equivalent or total R. So when two resistors, in this case, we can see in this case, when two resistors are connected in series, R equivalent would become R1 plus R2, or you can say simple addition, it will be 1 plus 2, that is 3 ohm. So that's the value of R equivalent. Now this circuit will look like, let's draw the direction of current and all also. So this is positive, this is negative, current starts from here, this is here, the same current is here, the same current is here, the same current is here. So second thing is that current is same in the entire circuit or across R1 and R2. And what will be the magnitude? To find the value, to find the magnitude, what we'll do is, we'll find the equivalent resistance of the circuit, right? So equivalent resistance, so the equivalent resistance will be R, which is equal to R1 plus R2, that is 3 ohm. Let's directly write 3 ohm here, right? So this is 3 ohm. This voltage is V, that is 12 volt. So what will be the value of current? As per Ohm's law, V is equal to I into R. So I will be equal to V by R. So that is 12 by 3, and it comes out to be 4 ampere. Right. So the value of total current in the circuit would be 4 ampere. So now I'll draw the same circuit back again because I got the value of total current. So this current coming out from here is 4 ampere. This was 12 volt. This is 1 ohm. This is 2 ohm, and the entire current is 4 ampere. Right. Now we can calculate the value of V1 and V2 voltages. So this is R1, this is R2. So the first thing which was asked is that what is the value of current through all the resistors which are connected in series. So we got to know that here also it will be 4 ampere, here also it will be 4 ampere. Now let's calculate the value of V1 and V2. So here it will be V1 and here the voltage will be V2. So what's the value of V1? V1 will be the current passing through the conductor, because what is V? I multiplied by R, Ohm's law. So what is the current here? Current is 4 ampere. What is the value of R1 here? The value of R1 is 1. So that is 4 volt. So the value of V1 or the voltage across R1 resistor is 4 volt. Similarly for V2, it will be I multiplied by R2, right? What is the value of I? It's 4. What's the value of R2? It's 2. That is 8 volt. So value of V2 is 8 volt. I'll also write it here, R1, V1, right? So this is 8 volt. Now we can also cross check that what was the total V here in the circuit. It's 12 volt. In series, we know that in series total V is equal to V1 plus V2. Total V was 12 volt. We got this and this. We add it and we see that this is also 12 volt, right? That means we have calculated everything correctly. So yeah, so this is how you solve when two resistors are connected in series. Now let's solve that when two resistors are connected in parallel. Find the value of I and V across all resistors. Same, right? So we see what's the value of current here. The current coming from the positive terminal is I, similarly this I, but at this junction the current is dividing itself. This is I1, this current will be I2. Here also it's I1 traveled through all path. This is I1, similarly this is I2, and here again this is I, which is I1 plus I2. Right. Second thing which we know about when the resistors are connected in parallel, we know that the voltage is same, right? And by that I mean that whatever this plus value is, the same is here. Whatever this minus value is, the same is here. That means across these two resistors also the voltage is 12 volt. Right. So the value, let's say that this voltage is V1, this voltage is V2, or the voltage across R1 is V1, voltage across R2 is V2, and this is total V. So V will be equal to V1 will be equal to V2. All the voltages are same in parallel, right? Because you can see the same plus and minus at the two terminals or at the end of R1 and R2 resistors, right? So I told you that the first step always is find R equivalent. Find the value of R equivalent. When two resistors are connected in parallel, 1 upon R equivalent will be equal to 1 upon R1 plus 1 upon R2. That gives 1 upon 6 plus 1 upon 3. It will be 6. It will be 1 plus 2. That is 3 by 6. So this is the value of 1 upon R equivalent. So it will be 1 by 2. So R equivalent will be 2 ohm. Right? That's the value of R equivalent. Now we got the value of R equivalent. We got the value of voltage across each resistor. Now we'll try to find the value of current I. Right? So for that we'll remake the circuit, and that is, this is 12 volt plus minus. This is the value of current I, and R equivalent. When two resistors are connected in parallel, we got one equivalent resistance as 2 ohm. Right? That's the circuit. So as per Ohm's law, V is equal to I into R. So total V is 12. Total R equivalent is 2. So what's the value of current here? It came out to be 6 ampere. That's the value of total I. Right? So total I is 6 ampere, and that was the only way I wanted to tell that what is the value of total current. For the individual current, that is I1 and I2, you could have directly you can directly calculate it from the circuit, that what's the value of I1 here. So I1 is this. I'm sorry. Yeah, for I1 definitely will be as per Ohm's law, which is V is equal to I into R. I1 will be equal to V1 by R1, and I2 will be equal to V2 by R2. We know that V is equal to V1 is equal to V2, that is equal to 12 volt. So I1 will be equal to 12 divided by R1. What's the value of R1 in the circuit? Sorry. Yeah, what's the value of R1 in the circuit? The value of R1 is 6 ohm. So it will be 12 by 6, and the value of I2, I2 will be V2 by R2, that is 12 by 3. You can check it again, and you can check few seconds back whatever was there, the value of R2. So this will be 3 4, and this will be 6 2. So value of I1 will be 2 ampere, and the value of I2 will be 4 ampere. These are the values of I1 and I2. So we got the value of voltages across each resistor. We got the value of total current in the circuit, this I, right? We got the value of I1 and I2 across respective resistors, right? So this is how you calculate when circuit or when you see circuit or resistors connected in parallel. Now this is the question where you